Okay, so our last lesson in Unit 7 Geometry and Grade 9 Math would be about circle properties. So circle properties are essentially a set of properties or like rules that you have to follow when you're solving a math question in a circle. Okay? So the first property states that chords in a circle that are equidistant from the center of the circles are equal in length. Chords of equal length are equidistant from the center of the circle. So what this means is that we have the center of the circle, O here, right? So if the distance from the center of the circle to each of these chords, so let's say it's a chord CD and chord AB, if the distance from the center of the circle to each of these chords are the same, that means that the length of these chords are the same. So AB equals CD. Okay, I wrote there. Okay, so and that goes the opposite way as well. So s so if two chords are the same length, that means that the distance to the center of the circle will be the same. Okay, so OS equals OT. So in case you guys don't know what a chord is essentially a straight line in a circle that has two endpoints, and these two endpoints both lie on the circumference of the circle. So that's called a chord. Some other important vocabulary in a circle is, let's say, an arc. An arc is a portion of a circumference of a circle. Okay, so you have a whole circle, right? Okay, let's say circle this circle. Okay, so you want to say, let's say, arc. An arc is like a portion of the circle, of the circumference of the circle. Okay. Our next property is that a line perpendicular to the endpoint of a radius of a circle is tangent to the circle. And a line that is perpendicular to the tangent of a circle at a point of tangency and the circle passes through the center of the circle. What that means is essentially we have a tangent, right? A tangent is a straight line that hits the circle once. Exactly once, okay? Exactly once. Straight line that hits the circle exactly once. And what this theorem is saying is that a tangent that passes through the circle at that point, let's call that point P. So at that point P and that point P and the radius, they form a 90-degree angle. Okay, so let's draw another tangent for you guys to understand. Okay, so let's say draw this one. This is, let's say, let's call that x, and this is the radius of the circle. So the point of intersection between this tangent and this radius of the circle would be a 90-degree angle. Okay, it's perpendicular. So that's essentially what this theorem states. Okay, our third property is that two tangents can be drawn from a point outside the circle. These tangents are equal in length. What this means is that basically if you have a point, let's call that, okay, let's go to this diagram. You have that point C, and you have two tangents that are extending from that one point and hitting the circle once, right? Those two tangents will be equal in length, basically. Okay, and the point has to be outside of the circle. Our fourth property is that if two angles are inscribed on the same chord and are on the same side of the chord, all angles are equal. The angles are equal. Okay, so you have a chord, and we have angles inscribed in the chord. So that basically means that if you see this I usually call this rule a bow tie rule. So I'm just gonna call that bow tie rule. Okay, because it kind of looks like a bow tie if you think about it here. Okay, it looks like a bow tie composed of two triangles like that, and you have a chord here. Right. Okay, you have a chord. So that basically means that these two angles are the same, and these two bottom angles are also the same. Okay, so let's call that one X. Let's call that Y. Call that Z. And let's call that K. So that means that Y equals X and Z equals K. And that only happens when these points are touching the circle. Okay, they're touching the circumference of the circle, and that they're part of the same. They're on the same like side of the chord. So these two be the same. These two be the same. Okay, so it's a bow tie rule. Whenever you see this diagram with two triangles like this, and it forms like a bow tie sort of shape, then you just know that these two angles that touching the circumference on the same side. So up top, these two angles are the same, and these two angles at the bottom are the same. Okay. Our fifth property is that if you draw a triangle inside a circle where all three vertices are on the circle and where one side is diameter, the opposite angle of the diameter is going to be 90 degrees. So we see this circle here, right? We have a triangle. We call this triangle a circumscribed triangle. Circumscribed. Okay. So this triangle is circumscribed, meaning that all the three vertices of the triangle is within the circumference of the circle. And what this theorem is talking about is that the diameter of the circle, so we call that AC, or diameter. So the diameter of the circle is the base of this circumscribed triangle, and the opposite side to that diameter will always be a 90-degree angle. Okay. So if the base of a circumscribed triangle is a diameter, then the side opposite to it must be 90 degrees. Okay, our last property and theorem would be a central angle is an inscribed angle are subtended by the same chord and are on the same side of the chord. The central angle is twice the inscribed angle. So what that means is that you have a chord AB, right? And you form an angle here. So that's called theta. And then you have another angle here, 20. So I usually, 2 theta. So I usually call this rule the arrow rule, because the shape it forms looks similar to an arrow. Okay. So when you see like an arrow like that, okay, that on the arrow like that, and they're this point, and this point, they're on the circumference of the circle. That basically means that this angle right here, let me draw in blue. This angle right here will be, so this is this angle here, I'll call that x. This angle is 2x. So the angle on the bottom side here, that's like between the bases of the arrow, would be 2 times the angle that is formed on top of the arrow, if you guys see what I mean. So basically, the angle below here is twice the angle that's touching the circumference up here. So that's basically the theorem. The last property of the circle theorems. So what this property essentially says is that in a cyclic quadrilateral, so cyclic quadrilateral, which essentially means that all of the vertices of a quadrilateral are on the circumference of a circle. Okay, and that means it's a cyclic quadrilateral. And the property states that the angles opposite in a cyclic quadrilateral add up to 180. Okay, so I've labeled the angles for you guys. Angles opposite to each other in a cyclic quadrilateral add up to 180. So x plus y equals 180. And c plus d equals 180. Okay? Alright. Now let's move on to some practice problems with all of the properties you guys have learned. Our first question, you're asked to solve for C and D. So you guys, first instinct, you guys should notice that it is a bow tie rule. As you can see, two triangles form bow tie, which means that C is 44. And you can in your exam or like your test, you have to justify as C and 44 degrees are both inscribed on the same chord and on the same side. Okay, gotta justify that on your exam or test. So you got C equals 44, and then we have C equals 44 there. But now, to solve for D, very important, to solve for D, there's another property that you must use. And I hope you guys see it, but cyclic quadrilateral. 4 endpoints are on the circumference of a circle, hence it is a cyclic quadrilateral. Let me just draw it. There. Cyclic quadrilateral, which means that opposite angles add up to 180, which means that C plus D equals 180, 44 plus D equals 180. So D should be 136 degrees. That's not right. Okay, our next. So let's go on to our next. Move this up here real quick. Okay, our next question. We have this, and the question asks us to find BC. Okay, how are we supposed to find BC? Okay, first thing I want you guys to notice is that, so in math, and especially in geometry, it's really important to notice these patterns that I'm about to show you guys. Boom. So you realize that that is a tangent to a circle because it only hits a circle once, right? So OA and BA would be perpendicular. So this forms a right triangle. Okay, so triangle BOA is right. Okay, is a right triangle. Because this is tangent, and we go back to our theorem earlier. Where's the theorem? Here. The radius and a tangent are always perpendicular at the point of tangency. So point A is the point of tangency, right? So it will be perpendicular to the radius. So hence the angle OAB would be a right angle. So how is that information going to help us? Well, in a right triangle, we can apply what? The Pythagorean theorem, right? Pythagorean theorem. So we can find BO. So BO equals square root of 6 squared plus 8 squared. So let me just plug that into the calculator real quick. It'll be 10 centimeters. Okay, so BO is 10 centimeters. This whole segment, this whole length here is 10 centimeters. Now, how do you even get BC? Okay, so to get BC, you notice that OC is the radius of the circle, right? And the radius is always, so this is the radius. The radius is always the same length from the center of the circle, right? So we can see that OA is also radius because radius extends from the center of the circle to the circumference. So this radius is also radius, so it's 6 centimeters. So we can say that OC is also 6. Okay, because it's these two, OA equals OC, because they are both radii. Not sure I spelled that right, but like, you know what I mean. Okay, so you have 6 there. So now to get BC, you just have to subtract 6 from 10. So BC will be 4 centimeters. Good. Okay, our last example. Okay, this is a bit harder, but I'm pretty sure you guys can do it. Okay, so you're asked to find, I forgot to label it. You're expected to find X and Y. Okay. So first thing you should notice is, boom, bow tie pattern. Right there. Okay. Bow tie pattern. And our theorem states that so we can call this angle E. Angle E and Y are same because they're inscribed on the same chord on same side. Okay, that'll be your justification. Okay, so to find angle E, you see this is a triangle, so and all the interior angles in a triangle add up to 180. So you subtract from 180. So angle E would equal 32 degrees. Change the color real quick. Okay, so since angle E equals angle Y equals 32 degrees. Boom. Okay, you got Y. Good. First part of the question done. And then now I'm gonna solve for X. But how? So another property I want you guys to realize is that it's a cyclic quadrilateral. Boom. All 4 points on the circumference of the circle. Hence, it's a cyclic quadrilateral. And what does a cyclic quadrilateral, what does the property say? Well, if we go back, it says that angles opposite to each other in a cyclic quadrilateral will add up to 180. So X and Y are opposite, right? So X plus Y equals 180. You got X plus 32 equals 180, so X should be 148 degrees. Boom. Okay, so hope you guys learned this lesson. And for this justification, I'm not gonna write it, but you know what? I'm just gonna write it for you guys. Well, because as quadrilateral ABCD is cyclic, and you can just go straight to this. solving. Okay, thank you for watching the video.